Hello all, my name is Preeti. I am working as an assistant professor in the Department of EEE in SRS College of Engineering. Today we are going to see a lecture on inverters. A topic is single phase AC voltage controllers. So we all know that single phase AC voltage controller is a device which converts from single phase fixed AC input voltage to the single phase variable AC output voltage without change in the frequency. It finds in various applications such as heating either for domestic or industrial applications, lighting control, speed controlling of AC drives and the starting of induction motor, transformer tap changing, etc. And now we are going to see the control strategies of AC voltage controller. There are two different types of the thyristor control are used in practice to control the AC power flow. The first one is nothing but on-off control and next one is called as the phase angle control. So in the on-off control technique, here we can say that thyristors are used as switches to connect the load circuit to the AC supply source for a few cycles of the AC input supply and then to disconnect it for the few input cycles. Here a thyristor does act as a high speed contactor, and whereas in the case of the phase angle control, a thyristor switch is turned on for a part of every half cycle so that the input supply voltage appears across the load and then turned off during the remaining part of the input half supply to disconnect the AC supply from the load. So these are the two control strategies whereas we are using for the AC voltage controller. And then we are going to see about the types of AC voltage controllers. There are two different types of AC voltage controller. The first one we can say that is single phase AC voltage controller and next one we can call it as a three phase AC voltage controller. The single phase AC voltage controllers operate with a single phase AC supply voltage of 230 volt RMS at 50 Hz in our country. Whereas in the case of three phase AC voltage controllers, it operates with a three phase AC supply of 400 volt RMS at 50 Hz supply frequency. And now we are going to focus on the single phase AC voltage controller using the OR load. OR load we can say it is called as a resistive load. So in this figure we can able to see that the single phase AC voltage controller with the OR load, whereas the two thyristors are connected in anti-parallel direction. So the waveforms of the source voltage and the gating pulses, load current, load voltage, the voltage across the thyristors T1 and T2 can able to see here. And here we can say that a thyristors T1 and T2 are forward biased during the positive and negative half cycles respectively. During the positive half cycle, thyristor T1 is triggered at the firing angle of alpha, whereas the T1 starts conducting and source voltages appear across the load from alpha to pi. At pi, both the E0 and the I0 falls to the 0 and just after pi, T1 is subject to reverse bias condition and it is therefore turned off, and during negative half cycle T2 is triggered at pi plus alpha. The T2 conducts from pi plus alpha to 2 pi and soon after 2 pi T2 is subject to reverse bias condition and it is therefore commutated. The load and source currents have the same waveform and the voltage across the thyristors T1 and T2 are shown very clearly here, and it is the output voltage equation. If ES is equal to root 2 ES sin omega t is input voltage and the firing angles of thyristors T1 and T2 are equal. So the RMS output voltage can be obtained from E0 is equal to 2 by 2 pi integral of alpha to pi to Es square sin square omega t d omega t the whole power of 1 by 2. It is the RMS voltage. So equal to 4 Es square by 4 pi integration of alpha to pi 1 minus cos 2 omega t d omega t the whole power of 1 by 2. When you solve this, we will get Es into 1 by pi, pi minus alpha plus sin 2 alpha by 2 the whole power of 1 by 2. It is the RMS output voltage equation of a single phase AC voltage controller using the OR load. So, the thyristor based AC voltage controllers having the high efficiency, flexibility in control and requires the less maintenance. And the disadvantage is that we can say that the AC voltage controllers, the interaction of harmonics in the supply current and load voltage waveforms, particularly at the low output voltage levels, it is a disadvantage. And also we are having so many merits like reducing the energy consumption and controls the motor speed and extends the equipment lifespan and enables a smooth voltage regulation. These are the various merits of using a single phase AC voltage controller using the OR load. So, the conclusion part is that a thyristor based AC voltage controllers having the high efficiency, flexibility in control and it requires the less maintenance part. So, let us see assessment, my dear students. What are the industrial applications of AC voltage controllers? You please let me know. And what is the output voltage waveform when the RL load is connected? RL means R is resistive load and L is the inductive load it is connected to. And I have referred the books like Alok Jain, Power Electronics and its Applications, Penram International Publishing, and Mohammad H. Rashid, Power Electronics Circuits Devices Applications, Pearson Education India, 3rd edition. So, thank you my dear students.